Determine the area of each figure. We're going to start with problem 4. This is a triangle, so the area of a triangle is 1/2 base times height. I'm going to change this mixed number into an improper fraction. 6 times 3 is 18, plus 2 more makes 20. So 20 thirds is our base. And our height is 2, which can be rewritten as 2 over 1. 1 times 20 is 20. 20 times 2 is 40. 2 times 3 is 6. And 6 times 1 is still 6. So you can write 46 centimeters squared. If your teacher prefers that you reduce that fraction, 40 and 6 both have 2 in common. 2 times 20 makes 40, and 2 times 3 makes 6. So you can write 20 thirds centimeters squared as your fraction for part 4. You can also change it back to a mixed number if you need to. In question 1, it asks us to circle the figures that are nets of cubes. To start, just pause here and think about which ones you believe would form cubes. Remember, a net is a 2D object that can be folded into a 3D object. We're going to look at each one specifically before we make a decision of whether or not we should circle it. Here I have net A. If I fold up net A, all the faces have been closed. So A does make a cube. So go ahead and circle A in your workbook. B is our next one. We're making sure all faces are covered and that there are no empty tops, bottoms, so on. So B can be folded up and around and down, so all of the faces of B are closed. B also creates a cube. Next up we have C. If I fold up the pieces of C, you can see that the bottom, the sides, and the top are all covered, so C creates a cube. D. Oh, these ones overlap, and we're left with a hole here. So D is not a net of a cube. They overlap and leave an empty spot. So D, no. E. Yes. E does close all faces of the cube. F. Oh, these ones overlap here, so we're going to end up with an open gap, so F does not create a cube. G. G. G does close all faces. H. Or your H is oriented like this in your book. Oh, it overlaps in one spot and leaves an empty hole, so H is not going to be the net of a cube. I. Yes, all faces of I close to make a cube. J. J overlaps in the back and leaves the top open, so J does not create a cube. K. Okay, this piece can't be folded because there's no empty piece there. Even if we were to slice along this edge, it would fold up and then this piece would overlap, but the top would not be filled. So K cannot be created to form a cube. L. Yes, all faces fold together to make a cube in L. M. And then we got the top and the left side. M has a face on all 6 faces. Closes to make a cube. N. Overlaps here, but the top is left open. O. Yes, O closes all the way. P. Yes, P is a cube. Q. Overlaps on the side but leaves the hole. So no for Q. R. Overlaps here, but leaves this side open. S. Overlaps here, but leaves the top open. So no for S. And T. Sides all fold up and covers the top. Yes, T makes a cube. Make sure you have them all circled for the ones that did create a cube. How might you create a net for this solid? How many faces does this right rectangular prism have? Well, there are 6. We have a top, a bottom, a left, a right, a front, and a back side. The 6 faces are all rectangular in shape, and we can use the dimensions of this prism to draw polygons or rectangles that make up this shape. We have the front is an 8 by 5 rectangle, and so is the back. The top is a 3 by 8 rectangle, and the side is a 3 by 5 rectangle. Here we see 2 8 by 5s, 2 8 by 3s, and 2 5 by 3s. So there's the 6 faces, each one representing a face of the prism. Let's look at problem 2 in your book and sketch the net of this triangular prism together. It says, sketch and label a net of the right triangular prism. Each square on the grid represents 1 square centimeter. Calculate the surface area of the prism by using its net. So we are going to draw the rectangle pieces that are on the sides. I have a 5 by 7 rectangle. So 5 by 7. Connected to that 5 by 7, I have a 6 by 7 rectangle. And then connected to that, we have another 5 by 7 rectangle. Attached to the rectangles, I have a 6 by 4 tall triangle. So this is 6, and we have 4 tall. 1, 2, 3, 4 tall. That is a height of 4. Now we're going to calculate the surface area. That means the area of each piece, and then we're going to find the total. So a 5 by 7 rectangle, base times height. 5 times 7 is 35. So this one is also 35. This one is 6 by 7, base times height. 6 times 7 is 42. Then for our triangle, it's base times height divided by 2, or cut in half. So 6 times 4 is 24, but triangles are half of rectangles, so that is an area of 12. Now to find the surface area, we're going to add all of those up. 12 plus 35 plus 42 plus 35 plus 12. Which is 136 centimeters squared. Remember to use the units. And it is a surface area, so area gets units squared. Sketch and label the net of the square pyramid. Each square on the grid represents 1 square foot. Calculate the surface area of the pyramid by using its net. So we have a square base, which is 4 by 4 because it tells us it's a square. And then our triangles are 4 wide, but 7 tall. So we're going to go up 7. 1, 2, 3, 4, 5, 6, 7. And then we'll also have a triangle coming off of this side. So 1, 2, 3, 4, 5, 6, 7. And this direction. Now we need to calculate the surface area for the prism, or pyramid, excuse me. It's a 4 by 7. So for the area of the triangle, the base is 4 and the height is 7. 4 times 7 is 28, but remember triangles are half of rectangles, so half of 28 is an area of 14, and all of those triangles are the same size. Then the square is base times height. 4 times 4 gives us an area of 16. So for the surface area, we will add 14, 14, 14, 14 for the 4 triangles, and 16 for the square, which gives us 72 feet squared. That is it for lesson 11. Check back in the playlist for future lessons in module 5.